Okay, good morning or afternoon or evening, whenever you're watching this. Um, Unit 2 is all about quadratic equations and solving them. And one of the methods to solving quadratic equations is factoring. So 2.2.3 is going to be a review of some factoring techniques. Okay, so let me back up here a little bit. Okay, so let's just go start with just basic factoring of numbers. So one method would be just using the factor tree. So I can break down 40 into 4 times 10. So we're breaking this down to all the prime factors. 4 can be broken down into 2 times 2, and 10 can be broken down into 2 times 5. Okay, so those are all prime numbers now. So there are multiple ways to break down a lot of numbers. So uh, 10 could be 25 times 4, 20 times 5, or simply 10 times 10. Okay, and 10 can also be broken down to 2 and 5, 2 and 5. Okay, so we want to identify the numbers that are common to both. It's the greatest common factor. Okay, so if they're not common to both, then it's not part of the greatest common factor. So both terms have 1, 2. Both terms have 2 2's, but they don't have this third 2. Okay, so part of my greatest common factor is going to be 2 times 2. Okay, both of my terms have 1 5. Okay, but they do not have a second 5 here. Okay, so all that is common to both those numbers is 2, a 2, and a 5, which would give us 20. Okay, so the greatest common factor of 40 and 100 is 20. Okay, and it's going to be the same method when we're dealing with three numbers. So if I have a 20, a 28, and a 24. And if you can do this in your head without doing factor trees, that's fine. But it's a method if it doesn't pop into your brain. 4 times 5, 2 times 2 times 5. Okay, and 4 times 7. 4 can be 2 times 2. Okay, so I'm just breaking these down until they're all prime. 4 and 6, and there are more than one way to do that, but I'm just doing the first way that popped into my head. So same thing. What's common to all these terms? Common to all these numbers. So every single one of these has a 2. Every single one has 2 2's. Okay, so that's for sure common to both. 2 times 2. And there is nothing else that all three of those numbers have. So the greatest common factor is in fact 2 times 2 or 4. Remember, that's the largest number that goes into all numbers. It's the greatest common factor. Okay, so let's just look at why is that not staying on that page? That is so weird. Okay. I'm going to pause this for a second and figure that out. Okay, I am. All right, I'm back. Sorry about that. Okay, so same strategy holds true when you're looking at expressions with variables as well. So if I have 16x and 36, I'm not going to do the factor tree. I am just going to, in my head, think about the largest number that goes into both of those. So the largest number I know that goes into both of those would be 4. Okay. 2 goes into both of them, but that's not the greatest common factor. The greatest common factor would be 4. And then the greatest number of x's. So this term has an x, this term does not. So x is not common to both. So my greatest common factor here would be a 4. Okay. Now let's come over here and look at these 3 terms. So the greatest number that goes into all 3 of those would be, I'll start with my smallest number. Does 30 go into all 3 numbers? It goes into 60, but not 110. So 30 is not common to all of those. So if you look at your smallest number to see if it goes into all of them, that would be your greatest common factor. Since 30 doesn't go in there, I need to find a number that does go into all 3 of those. I could do a factor tree, but I'm going to be a little bit lazy this time, and I know that 10 is the largest number that goes into all 3 of those. What is the largest number of x's that goes into all 3 of those terms? So all terms have at least 1x. All terms have at least 2 x's. All terms have at least 3 x's. But it's the most that they have in common. So the common factor would be x to the third. Okay, let's look at a couple more examples of that. Okay, so we have a to the third b minus ab to the fourth. So what's the greatest number of a's, okay, that they have in common? A, they only have one a. Okay, what's the greatest number of b's that they have in common? They only have one b in common. So that's the largest number of a's or b's that go into both of them. So in other words, I can't get 2 b's out of this term, and I can't get 2 a's out of that term. So ab is my largest. Okay, so again, we have 4 terms here. What's the largest number of a's that go into each term? Okay, this last term here doesn't have any a's, so they don't have any a's in common. So then we have to see if they have any b's in common. What's the largest number of b's that are in all 4 terms? Okay, this one only has one b, so the only thing these 4 numbers have in common is a b. That's the greatest common factor. Okay, and one thing to keep in mind, what is factoring? Factoring is essentially just multiplication in reverse. So in other words, we're looking to see what you multiply 6x to the third by. That would give us 78x to the fifth. Okay. So what do I multiply 6 by to get 78? I would multiply that by 78 divided by 6 would give us 13. Okay, so I've identified, so now I know that 6 times 13 is 78. Now, what would I multiply x to the third by to get x to the fifth? It would be x to the second. Okay, so I can just double check my work here. 6 times 13 is 78, and x to the fifth times x to the second is x to the fifth. Okay, and that's what we wanted here. So I'm just finding out what number I'd multiply x to the fifth by. Okay, now let's do some factoring of binomials, and that's going to be, we're going to be using that in solving quadratic equations. So what number goes into both 2y and 30? What can I factor out? I can factor 2 out of both terms. So if I take that 2 out of both those terms, what am I left with? 2y divided by 2 would just be y, and 30 divided by 2 would be 15. So I've factored that down. Okay, so what term goes into, let me write this whole thing out here real quick. So 5x to the third, y to the fourth, minus 25x squared, y to the fifth. My pen's running out of some batteries here. Okay, so what's the common number, the largest factor for 5 and 25? Well, 5 goes into both of those. That's the largest number that would go into both. What's the largest number of, whoops, what's the largest number of x's that goes into both of those terms? That would be x to the second. They both have 2 x's. And what's the largest number of y's that go into both terms? It would be y to the fourth. Okay. So, so let's break this down by uh, each term within that. So each term, so there were 2 terms that we broke down. Okay, so we took a 5 out of the first term. That leaves us with 1. Let me give myself a little more room here. Okay. We took a 5 out of the second term. That left us with 5. Okay, we took 2 x's out of that first x term here. That left us with 1x. Okay, and again, we took 2 x's out of this term. That was all the x's that were in this second term here. So we took out all the x's from that second term. So therefore, I'll have no x's here. How many y's did I take out? I took out 4 y's. So that's all of the y's from this first term. Okay, the sign stays the same. How many? If I took out 4 y's from this term right here, how many y's am I left with? I'm left with 1 y. Okay, so so I took out the greatest common factor, which was 1, 5, 2 x's, and 4 y's, and then I saw what I was left with each term. Okay, let me look at one more example, then I'll wrap this up. So we have 15x squared plus 5x. Okay, what can I take out of both of those terms? I can take out a 5 is common to both. Okay, I take out a 5 from both terms. And I can take out, they each have 1x. Okay, so what does that leave us with? Okay, if I took out a 5 from 15, that leaves us with 3. If I took out 1x from 2 x's, that leaves me with 1x. I took out our 5 from 1, 5. That leaves me with 5 divided by 5 is just 1. And I took out 1x here. Okay, so I did that. X is taken out, so I'm left with this. Okay, so in other words, if I factor something correctly, when I go back and if I were to multiply again, I should end up with the original number. So let's just check that. 5x times 3x would be 15x squared. 5x times 1 would be 5x. Okay, so when I check our work or multiply it, I get the same thing that we started with. Okay, so this is we're going to be using this in solving quadratic equations. This is just a quick review for you. So there's a assignment on Math Excel, and I will be available for questions in class. Good luck.